The last part of this section finally is we're going to actually put this to a real world use, something that you'll be able to use when you go to college actually, and you're starting to look at the cost of college and what loans are going to cost you when you get done with college. It's interesting to know this stuff. It's a lot of college kids don't realize, and be able to help you throughout the years. And even, I'm older now. I made a decision to buy a bike last year, and I sat down and I figured out how much it was going to cost me before I made that decision. So this information here, you've probably seen it before in another class, but this here's an application of the exponential function that we've been talking about, and in a different base as well. So we're going to let P be the amount of a deposit, or P being principal. We're going to have T be the number of years, or A be the balance, and A is the balance after that many years. R is the annual interest rate, and N is the number of compounding times per year. All right. So here's two equations. When it's compounded like n times a year, so maybe it's compounded twice a year, or maybe it's compounded quarterly, so that'd be 4 times a year, or maybe for some odd reason they just compound it 10 times throughout the year randomly. I don't know. But we'd use the first formula there, where area equals the principal times 1 plus r over n to n to the t. So here's our other base that we were talking about. It kind of fits into this chapter. If it's compounded continuously, so that means each day it's compounded, compounded, compounded. All right. So we use the exponential function. So that's I actually call it the PERT formula, principal times e to the RT. So that's what we use if it's compounded continuously. All right. So knowing those formulas, I'll leave those up there so we can see them here. It says a deposit of $2,500 is made in an account that pays an annual interest rate, an APR, of 5%. Find the balance of the account at the end of 5 years if the interest rate is A, quarterly, monthly, or continuously. So let's go ahead and let's write all three of those equations out, and we'll type them into the calculator and figure out what's going on here. So these first two, quarterly and monthly, we're going to have to use this formula here. It's not continuous, so we're not going to use the PERT formula. So we're going to use that. So let's see. Compounded quarterly, so it's going to happen 4 times. So our money after 5 years, that's A, is going to equal our principal, so 2,500, times 1 plus our rate, which is 5%. So we're going to change that to a decimal, so it's 0.5 all over n. And n was our number of times it's compounded. So that's going to be, if it's quarterly, it's going to be 4 times 4 times time. So it's over 5 years, I believe, right? So 5. Okay. So that'd be for A. For B, if it's compounded monthly, it's going to be the same thing, except for we're going to put 12 instead of 4. So it's going to be 2,500 times 1 plus 0.05 all over 12 times 12 times 5. All right. And then C, continuously, is going to be 2,500 times e to the rate, so 0.05 times our time, which is 5 years. All right. And all we have to do here is we just have to plug that into a calculator, and we get to solve a pretty easy formula. Okay. So this is just plugging and chugging. Let me get my calculator up here. That's what I was trying to do. And we can type this straight into our calculator. We can say 2,500 times 1 plus 0.05 divided by 4 raised, that all raised to the 20th power. And so after 5 years, our $2,500 is going to be worth $3,205 and almost 10 cents. Okay. So that was quarterly. Here is monthly. 2,500 times 1, and 1 plus 0.05 divided by 12 to the 60th power. And so if it's compounded monthly, it's actually $3 more, $3.30 more. And then if it's compounded continuously, so 250 times e to the 0.05 times 5. It's actually $2 more. And actually, if you think about it, if it's compounded continuously every single day, it's going to be much better than just 12 times out of a year. So anytime if you could ever get an interest rate that's compounded continuously, I'd take it. But there's an example of what we've been talking about. What you need to look out for is loans that are compounded continuously and stuff like that. So that'll help you make a decision if you ever want to buy something, or as you're going to college and looking at loans. I would like you to do this example yourself. Go ahead and you can pause it. Do that example yourself, bring it to class and turn it in, and we'll talk about it then. Hope this helps. We'll see you in class.